Hi, here in this given problem, this is a smooth surface, a block of mass m, capital M kept over it, attached with a horizontal spring. Horizontal spring for which the stiffness is 130 Newton per meter. A small block has been kept over it also, whose mass is m is equal to 1.25 kilogram. Mass of the heavier block, capital M, 6.0 kilogram. The friction, coefficient of static friction between m and m, between the two blocks, mu s, that is 0.30. Okay. Now, as the m, capital M, will be oscillating, the small m kept over it, it will also move along with the capital M due to the friction. So, while this m is in simple harmonic motion, small m will also be in motion with it due to force of static friction acting between the blocks. Now, as maximum acceleration, that is at the mean positions, so maximum force on that small m will also act at the extreme position. Sorry, not at the mean position, it should be at extreme position. So, maximum force on m will also act at extreme position. And as acceleration a max, it will be given by a omega square, taking its magnitude only, that is a omega square. A is the amplitude which is missing. Actually, we have to find this amplitude provided the block, the smaller block, does not slide over the heavier block. It means smaller block will oscillate sticked over the heavier block only when the force acting on it that is equal to the force of static friction acting between the two blocks. It means that F should be equal to small f. Small f stands for force of friction. This capital F, it will be given by product of mass of the objects, combined mass m plus m multiplied by maximum acceleration a max. And Fs, this is mu s times weight of the smaller block only, mg, as the surface is horizontal. Okay. Now, using an expression for stiffness, this is given as omega square. So, and here also mass should be total mass of the system, m plus m into omega square. So omega square will be given by k by m plus m, and already we have seen a max is a omega square. A max is a amplitude into omega square. Omega square we know that is k by m plus m. So finally, using this equation, we get m plus m multiplied by a max, and that is a k divided by m plus m should be equal to mu s times mg. So cancelling this m plus m. No, sorry, I have made a mistake. This force should be on the small m only. So making this correction, this is small m only, and that will be cancelled. And omega square we already know. So a max is equal to a omega square means ak by m plus m. So again, putting this value in the equation we have obtained above. So a max, that is a k m plus m, is equal to mu s times into g. So a will be given by mu s times m plus m into g divided by k. So plugging in all the known values here, amplitude will be given by mu s 0.30, mass 6.0 plus 1.25 multiplied by g 9.8 divided by k, which is 130. So this a is calculated to be equal to 0.164 meter, or we can say amplitude, it should be maximum amplitude should be 16.4 centimeter, beyond which the smaller block kept over the heavier block will not oscillate along with this heavier block. Thank you.